Dr. Jones checking in. This is A&P 2, Lecture Test 3 video, checks notes 4. And we are starting middle bottom of page 6 at section 19.4. White blood cells contribute to the body's defense, which looks like this. We just did the hemolytic disease of the newborn, HDN. And so we're here. Okay. White blood cells. White blood cells as a group are called leukocytes, which we already said. They have no hemoglobin, so they do not carry oxygen or carbon dioxide. White blood cells have no involvement in gas exchange or gas transport. They do have nuclei and organelles, unlike red blood cells. They are your immune response. They're in charge of it. And you have 5,000 to 10,000 leukocytes per microliter of blood. Okay, so the white blood cell, here are the different white blood cells: neutrophil, eosinophil, basophil, monocyte, and lymphocyte. Okay, we'll use a keyboard arrow then. That didn't work. How about now? Okay, now it worked. Very good. So, characteristics of white blood cells. They can migrate out of the bloodstream. They have amoeboid movement, and I have a picture here of phagocytosis, which is amoeboid movement, where the little pseudopods, pseudo means false, pod means foot, come around and surround the bacterium, in this case, and absorb it and combine with a lysosome to make a phagolysosome. Phagosome, because it's phagocytosis, which is cell eating. And when then that combines with the lysosome, it's a phagolysosome, and it digests the material, absorbs the nutrients it needs. Exocytosis for the wastes. So the amoeboid movement, and amoeba does the same thing with the pseudopods surrounding and absorbing stuff to eat it. So that's why it's called amoeboid, because that's what an amoeba would do. And it is attracted to chemical stimuli, which is positive chemotaxis. Okay. Next, some are phagocytic. These three are phagocytic: the neutrophils, the eosinophils, and the monocytes. And again, phagocytosis is cell eating. Page 7. Specific defenses. There we go. Specific defenses are the lymphocytes, and they attack specific pathogens and proteins. The non-specific defenses, we're going back. Okay, the specific defenses are the lymphocytes. They attack specific pathogens and proteins. All the rest, the monocytes, basophils, eosinophils, and neutrophils, are non-specific defenses. They just show up and attack stuff. Anything, everything. The lymphocytes, the specific defenses, are how you're able to get chickenpox and then not get it again. Fingers crossed. It doesn't always work. But the idea is the lymphocytes remember the chickenpox and grant you immunity so that you don't get chickenpox again. In theory. Most of the time. Just not all the time. Neutrophils. 50 to 70%, so these are the most numerous of all the white blood cells. 50 to 70% of circulating white blood cells are neutrophils, also called poly, which means many, morpho, which is shape, nuclear, which is the nucleus, and then leukocytes. All the white blood cells are leukocytes. So it's the polymorphonuclear leukocytes, because look at this nucleus. It has poly, lots, morpho, shapes, nucleus. So it has a nucleus with lots of shapes. So neutrophils, and it can have 2 to 5 lobes of the nucleus. Neutrophils are the first white blood cells at an injury, and they specialize in attacking and digesting bacteria. Neutrophil activity attracts more neutrophils, so when they get activated and start working, then that attracts more. And pus is made of dead neutrophils and cellular debris. You may recall pus as our fifth sign of superficial infection. It was rubor, calor, dolor, tumor, and pus. So rubor, red, calor, heat, dolor, pain, tumor, swelling. Pus is Latin for pus. And it's dead neutrophils and cellular debris. Next, and the neutrophils, the first three on the list, the phils, neutrophils, eosinophils, and basophils. So those three are granulocytes. They have granules, visible granules that stain. And so you see those little kind of purple dots. Those are the granules in the neutrophils. In the eosinophils, those granules take up an orange stain, the eosin stain. And so the eosinophils look just like the neutrophils, except they're slightly orangey, more orange. So the eosinophils are 2 to 4% of the white blood cells are eosinophils, and they attack by excreting toxic compounds. So they don't have to ingest something to attack it. So the eosinophils attack bigger things like parasites, especially active against parasites, and are sensitive to allergens and injury. Next, and these are also granulocytes because they have visible orange granules. And again, the orange is a stain that these cells take up more readily. Basophils take up the I forget what it's called, stain, and it is a dark blue. And the basophils, the granules are so many and so dark that in many of them that we have in class, you can't even see the nucleus. See, this is a bilobe nucleus that you can clearly see. Most of the basophils, you can't even see it because there are so many darkly stained granules. So the basophils are the least numerous of all the red blood cells at less than 1%. At less than 1% of white blood cells, basophils are rare. They migrate to injuries and release histamine and heparin. Histamine dilates the blood vessels and causes swelling, and heparin is a blood thinner and prevents blood clots. So the basophils do inflammation. Basophil activity attracts eosinophils and more basophils. So this is the last of the granulocytes. The granulocytes all in the name phil. Neutrophil, eosinophil, basophil are all granulocytes. Next are the agranulocytes, and they end in cyte. So that's the monocyte and the lymphocyte are agranulocyte. Here's the thing, we have since learned that they do have granules, they just don't stain. So, but we keep the terms because the granulocytes have their own pathway to be created in the bone marrow, separate from the monocytes and the lymphocytes. So it is still a useful term, although it is completely meaningless. So there's that. Monocytes are 2 to 8% of white blood cells, and they are macrophages, the very large monocytes. And they leave the circulation to become macrophages. Monocyte activity attracts neutrophils, monocytes, and fibroblasts. Remember, a blast cell is a builder cell, and it builds fibers. And so this will be important in building scar tissue. And our last but not least white blood cell are the lymphocytes. And lymphocytes are 20 to 30% of white blood cells are lymphocytes, making them the second most numerous. And they are solely responsible for specific immunity, as we mentioned. There are 3 types of lymphocytes. The T cells attack foreign cells. There's a bunch of different types of T cells. B cells make antibodies. So when you become sensitized to the Rh surface antigen, It's the B cells that make the anti-Rh antibodies. And then, of course, the natural killer cells, which are fun, and they help prevent cancer. So here we have written under my picture. I wonder if I can move this. Nice. Never let monkeys eat bananas. And this is a mnemonic to help you remember how, what percentage of these you find. Well, not the numbers, but just the order. So the neutrophils are most common, and then lymphocytes, and then monocytes, and then eosinophils and basophils are the least numerous and are in fact rare. So never let monkeys eat bananas is your mnemonic, and there's at least one test question on that, probably more than one. Okay. That was page 7. Did I start the time? I didn't start the timer. Again. Let's put it on 10 minutes. See where that gets us. Okay. The differential count is the number of each type of white blood cell out of 100 white blood cells. Leukopenia is a low number of white blood cells. Leukocytosis is a high number of white blood cells. And leukemia is extreme leukocytosis with more than 100,000 white blood cells per milliliter, usually micrometer, I can't remember right. It usually indicates a cancer of the white blood cells. And again, here's what the white blood cells look like. Erythropoiesis is when you make red blood cells. Leukopoiesis, because leukocytes are white blood cells, leukopoiesis is when you make white blood cells. Lymphocytopoiesis is when you make lymphocytes. And thrombocytopoiesis is when you make platelets. So platelets in humans are not cells, but in other animals they are cells, and those cells are called thrombocytes. So thrombocytopoiesis is making platelets, but it's the term thrombocyte as if they were cells, even though we don't make platelets as cells, we make them as cell fragments. But the term still is part of the process. Okay, and then next of that whole chart, these are the terms that I need you to know. I'm gonna move me off screen a little bit. Okay, there, now you can see the whole thing. So for all of these, the red blood cells, the platelets, and all the leukocytes, the white blood cells, you start with a hemocytoblast. Hemo means blood, cyte means cell, a blast cell is a builder cell. So there's a cell that builds blood cells. Build blood cells. Easy peasy. And that splits off into either a myeloid stem cell that makes all of these, or a lymphoid stem cell that only makes lymphocytes. Lymphocytes, as you recall, are specific immunity. There are 3 types. They have a different set of functions than the rest of the white blood cells. And they do have their own stem cell, the lymphoid stem cell. The myeloid stem cell can make a progenitor cell, which can make a proerythroblast that makes a red blood cell. And we did learn a few other terms in there. We said a proerythroblast makes an erythroblast, which makes a reticulocyte, which makes a red blood cell. But I couldn't fit all of those in without making the rest of the chart weird. So I'm assuming that you know that there's an erythroblast and a reticulocyte and then a red blood cell. Okay. Or it can make a megakaryocyte, and that makes platelets. Or it can make a progenitor cell, which if it makes a myeloblast, makes a granulocyte. Or if it makes a monoblast, makes a monocyte. Okay. So monocyte formation is stimulated by MCSF. M for monocyte, CSF for colony stimulating factor. Colony stimulating factor. So MCSF forms monocytes. Well, it's the hormone that increases the production of monocytes. Granulocyte formation is stimulated by GCSF, G for granulocyte. And what are the granulocytes? The granulocytes are all of the phils. Some guy named Phil named these. I'm just joking. Basophil, eosinophil, neutrophil. All of the phils are granulocyte. So fill your brain with that knowledge. And so the hormone that makes that is the GCSF for granulocyte, MCSF for monocyte. And then monocyte and granulocyte formation is stimulated by GM-CSF. Get it? Granulocyte, monocyte, GM-CSF. It's right there in the name. And monocyte, granulocyte, platelet, and red blood cell formation all together are multi-CSF. And red blood cell formation is stimulated by, we've said this before, EPO, which is erythropoietin, which causes erythropoiesis, which is red blood cell formation. So of that whole picture in the book, these are the terms that I expect you to be responsible for our test. And here's that picture. So of that, we are learning erythropoiesis, EPO, proerythroblast, erythroblast, reticulocyte, erythrocyte, and the ejection of the nucleus at day 4. We've got thrombocytopoiesis, which is making platelets from a megakaryocyte. We've got the granulocytes are formed from a myeloblast because of GCSF. The monocytes are formed by a monoblast because of MCSF. And those are both stimulated by GM-CSF from a progenitor cell. Also progenitor cell, progenitor cell, progenitor cell. Just a whole list of them. And all of this myeloid stem tissue, which is these multi-CSF. So the multi-CSF does the erythropoiesis, thrombopoiesis, making of granulocytes and monocytes. The lymphopoiesis, I need a different color now. Oh, I'm feeling the neon green. That's so weird. I hate neon green. Lymphopoiesis, you have the lymphoid stem cell, the lymphoblast, and the lymphocyte. So lymphopoiesis has its own stem cell, its own little process, little shebang going on. But all of these start with, I need a different color, magenta, a hemocytoblast. Hemo means blood, cyte means cell, and a blast cell is a builder cell. Okay, so of those terms, that's what we need to know, what we wrote on the chart on page 8. Page 9. Wait, are we going to do page 9 on this video? No idea how long I've been talking. And we started on page 6. Did we really start on page 6 in this video? Did I skip the page? Yeah, 6, 7, 8. 6, half of 6 through page 8 is enough for one video. So we are going to stop there. And this, I'm still like half off screen here. Sorry. Okay, so there we go. This has been a lecture video for A&P 2, lecture test 3, and this was video 4 covering note sets, the bottom of page 6, all of 7, and all of 8, which was blood and stuff, where we're in the blood chapters, so that makes sense. So thank you as always for tuning in. I appreciate y'all tuning in and learning things, especially those y'all doing this completely online. I know it's different and a pain, and I know, and I'm sorry, and just keep on keeping on, because the education must go on, and the world needs healthcare workers now more than ever. So we'll keep it. Just keep studying, right? Just keep swimming, except we're going to just keep studying. All right. So I'm going to Command, Control, and then Escape. Thanks, y'all.